Hello, welcome to my YouTube channel, Emerging Engineer. Today I am going to present you a report of line follower robot. Emerging Engineer. Today I am going to present you a report of line follower robot. A line follower robot is an autonomous robot that follow black or white line. It is made of some sensors and motors, DC motors, and motors is powered by some battery, and it is programmed by a software. Let's start from some introduction of line follower robot. Line follower robot is an autonomous robot that is able to navigate a path that is predefined, such as a black line or a white line. This robot uses sensors. It can be IR sensors and ultrasonic sensors, but IR sensors is used specifically to detect a white line or a black line, and ultrasonic sensor is used to detect any obstacles come in front of robot that senses and stop or any decision criteria of sensor robot. Then the main thing is the microcontroller. Microcontroller is a brain of robot. Microcontroller get data from sensors and then decide which motor to run. Direction and speed of motor is controlled by motor driver and microcontroller. Sensor. The type of sensor used to detect lines such as infrared or reflected light sensor will be impact the robot's ability to accurately follow the line in different lighting conditions and on different surfaces. It is important to ensure that selected sensors are reliable and affordable. It should be cheap and can do our work accordingly. Then motor. We can use DC motor for our project. It is cheap and good. It has almost 250 RPM. Motor control. The motor control is the ability to control the speed and direction of its motor will be critical factor in its ability to accurately follow the line. The robot should be designed to handle different speeds and directions smoothly. Then our robot is powered by some battery power sources. We can use for prototype a charger adapter for only prototyping. Then after prototyping testing, you can use a battery or cell DC cell. To program this all things, sensors and our microcontroller, we need to use a software. That software is easy to use and easy to bug detection. We can use Arduino IDE or Atmel Studio, Microchip Studio. Cost is very important in this project. Any project, the cost optimization should be our highest priority. It should be cheap and reliable. The next thing we can discuss is it's how to break down our project in small steps and then follow that step to complete our project. Designing. The first is designing. First of all, make a design of schematic and some interfacing design, how to interface. Look at some researches at Google. Then after finding some search data, use one by one sensor interfacing. By that you can get a confidence and a motivation to make project in steps. After interfacing, you got a lot of motivation and confidence. You should forward to next design, that is PCB designing. After PCB designing, print out and make made on PCB at board. After PCB designing, soldering everything, then do a final test. In final test, you have to check everything accuracy and its reliability conditions, checked in different conditions. Block diagram. We are using voltage sensor, IR sensor, current sensor, and encoder as our input, and we are using 3 IR sensors, which is a very basic. So we make a basic project to follow a line. 3 IR sensors. One I use at analog and the other 2 are using digital. We can use any pin, digital or analog. They can do work same. Getting data, if it is high, it can move forward, otherwise low and drop. Any condition. That voltage sensor is connected to analog pin A1 to detect voltage of our battery. Then current sensor is giving input to our microcontroller to detect current of our motor driver. If it is exceeding, we can decide cut our current and connection according to encoder. Encoder is used to detect the RPM, calculate the RPM of our wheel. Then interrupt is very important in this project. If it is in any emergency condition, you can use interrupt to stop that robot, or you can also use it to start your robot. Then all the things can be stored in an SD card. SD card is used for data initializing and then do data storing. If your robot stop working, you can get data and check at what conditions causes it to stop, like is voltage exceeded cause damage, or current exceeded, voltage low, anything. Then we use enable motor driver. Motor driver enable is used to control the RPM, PWM pin and RPM of our motors, to control the speed of our motor basically. Then motor and our motor driver is powered by a power source, that is battery, and all thing voltage and current sensor encoder speed are displayed at a LED, that is OLED display. OLED use I2C interface. One pin is clock and other is clock data, serial data, and our SD card is on SPI interface, working on SPI interface. It has master in slave out, master out, slave in, SD and SCK pins. How sensor decide which motor to run or stop. Basically, decision criteria of motor controls. If all sensors are at black line, go straight. If right sensor is at 3 sensors are on black line, it should move in right, and our left motor should be run, and our right motor should be stopped to turn at right side. Same as for left side, if our left sensors are on, it should turn at left, and our right motor should be stopped, should be done, and our left motor should be stopped. And if our utmost left and right both sensors are at line, it should be go straight or stop. You can use any condition for that. If no sensor is at line, you can use it for forward direction, running motor run at forward direction. Let's discuss some flow chart. Starting both sensors are at black line. If yes, then motors should go in straight forward. If no, then only the left sensor, check the condition, only the left sensors are black. If that condition is true, you should be going left. If otherwise, you should check is right sensor at black line, then should be turn right, otherwise it should be going forward direction. Budget. The most important thing in our project is optimizing the budget. Use cheap and reliable products. Avoid burning the things. Mixing schematic diagram and then PCB designing. The most important is problem faced and conclusion. I faced a lot of problems in this project, like short shorting our circuit, soldering. The most important thing is soldering. I mostly when I solder a pin, it came out after some hours. The solution of that is to make the pad of the soldering should be larger. Pad should be a big size. That can give a solution of your pin out problem. Then I face a problem that when I interface everything on the Arduino, on the board, it is giving some delay. Due to that delay, it is missing that line and decision criteria missed due to some delay, because our function run line by line. If one function is running and other function wait for that function to complete and motors are running, it misses the decision criteria to follow the line. It is a big and major problem in our project. That's all in this project. In final testing, the final testing of flying robot is an important step in the development process to ensure that robot is able to perform as intended of your criteria, your demand. The robot was tested on a variety of lines, including different widths and surfaces, to ensure that it can accurately follow the line under different conditions. Both should be tested at different speed to ensure that it can follow the line accurately at any speed. The robot reliability should be tested by running it in extended period of time and ensuring that it does not fail or malfunctioning. Robot was tested for safety to ensure that it doesn't pose any risk to the user or the environment, and the robot was also tested for power consumption and battery life to ensure that it can run for the desired duration on single charge. Current sensor. Its name is ACS7125 for use can detect 5 ampere current. The 3 pins is for one for VCC 5 volt. In the middle it is for the analog voltage, and the third one is the ground. It is connected like a pattern that power supply, positive power supply and power supply for negative, I mean ground. It has a power indication light chip, ACS chip, performance characters like sensitivity table is here given. You can check its 5 ampere maximum and every sensitivity optimized accuracy. You can check anything from here according to your requirements. It is the voltage sensor. Input volt from 0 to 25 detect, and the voltage detection range is 0.0245 to 25 volt, and resolution is 0.00489 volt. No external component needed for this. Easy to use to interface microcontroller. And tachometer is used to measure the RPM of our wheel. It has 4 pins, can be used as analog and a digital pin, VCC ground. Ultrasonic sensor to detect any obstacle in front of the board. One is for echo, send signal, receive signal. Trigger is to send signal, and echo receive that signal. Distance measuring, it gives us it show the distance, VCC and ground pin.